this short video, we're going to look at the adiabatic humidification process on a site chart. For this example, what we're going to do is we're going to humidify air from 80 degrees at 13% RH to 50% RH. And as soon as you get two properties of air, you can find yourself on a site chart. And once you can place yourself on a site chart, you can actually calculate all the other properties of air. You could do this as well with an app or a piece of software. So our starting point, 80 degrees and 13% RH. These green vertical lines represent our dry bulb conditions, which is what the 80 degrees references. And you can see they're vertical lines, and here's 70, here's 80, here's 90. We want to be on 80, so we're somewhere on this line here. And then we're told that our starting point is 13% RH, or relative humidity. Now these black sweeping curves here are the relative humidity lines, so you can see 20, 40, 60, 80. And then this one here on the edge of the site chart is 100% RH. And this is saturation. The air is not capable of holding any more water vapor in it. It's maxed out. Now we're at 13%, which would be below the 20 down here, and so you can see we now been able to get our starting place of 13% RH and 80 degree dry bulb air, and now we're going to apply the adiabatic humidification process to it. Now it looks like this. And so we see we started at basically at 13, and we're moving across here. So we should need to stop and say, what is an adiabatic humidifier? Now, this is different from an isothermal humidifier where the water has already been boiled. It's already been converted from a liquid to a gas, and you're just introducing the steam into the air, the water vapor into the air, so it won't change the temperature. In this case, what we're doing is we are exposing the air to liquid water, and that water is evaporating in the airstream and turning itself into the gas. And the energy for that water to evaporate is coming from the air itself. And so let's just stop and think about that for a minute. If you want an example, think of a residential or home air conditioning pad type humidifier on a furnace. Some of the return air is run across a pad that's wet. That air is coming back. It's relatively warm. It's from the house. And what happens here is the air goes across here. The sensible energy of the air is being used to boil the water. And so adiabatic means at a constant energy, and so what you got here is this line moving along in this direction, parallel to the wet bulb and the enthalpy lines, and the sensible heat of the water is dropping. Look at the, the air is dropping. See the air temperature, the dry bulb is going from 80 to 75 to 70 to somewhere down here around 55 degrees, and that energy isn't being picked up by a cooling coil and removed. It's being used to boil the water, to allow the liquid water that's exposed to that airstream to turn itself into a gas, and we see that as an increase in relative humidity. So we started at 13% and we finished at 50%, but because this was adiabatic, we actually changed the supply air temperature. So quite a specific process. Well, let's look at all of our dry bulb and wet bulb conditions. So we started at 80, and as we just explained, we converted the sensible heat that was already in the air and used that energy to boil water, but it meant the sensible heat was removed, converted, and it changed the supply, the temperature of the air, the dry bulb temperature. We dropped it almost 16 degrees. So now the air has been cooled down here to 64 degrees. So cooler, but with more humidity in it. And you'll notice that we followed the same wet bulb line, right? This is really kind of the first indicator of what wet bulb means, is that we were able to start with 54 degree wet bulb here and follow it to 54 here. That's parallel to the wet bulb lines and parallel to the enthalpy lines. If we look at the humidity ratio, that's these blue lines that run horizontal across here. And just remember that humidity ratio is the amount of mass of water vapor in the air relative to the amount of mass of the air itself, the dry air. And in this chart, we're using grains per pound. A grain is, there are 7,000 grains in a pound of air, so it's just a unit of measure of weight or mass. And so you can see this is 60 grains, this is 100 grains, meaning that there are 100 grains of water vapor in 1 pound of air. So the higher up you are in this chart, the more moisture there is in the air, more water vapor in it, the further down, the drier the air. All right. So we started here at 80 degrees and about 13% RH. We did an adiabatic humidification process here and raised this humidity from 20 grains to 45 grains per pound. So we took sensible energy that was already in the air, used it to boil water to convert it from a liquid to a gas, and we raised the amount of water molecules in this air from 20 grains per pound to almost 46 grains per pound. Now the last thing we'll look at is enthalpy. This is the internal energy of the air, and the reason this is an adiabatic process is we're not changing the energy. Well, we're leaving it the same, but we converted the form in which it is. We started with air that was hot, 80 degrees, but relatively dry, only 13% RH or 20 grains. And then we used that heat, the sensible heat that was in the air, to boil water. And that had the effect of cooling the air down to about 65 degrees, right? But allowing us to add water molecules to increase the humidity of that air from 13 to around 13% up close to 50% here. And so the air started with 22.3 BTUs of energy in every pound of air, and it ended at the same condition. But what we would see is that there's less sensible energy in the air and more latent energy. So if we separated those two out and calculated them individually, we would see the ratio had changed, but not the total. So by the way, if you're wondering what processes where you might see this, you might see this in someplace like an electronics manufacturing or chip manufacturing, where it's important to keep the humidity up in the labs. There's a lot of internal heat gain in that space, and they use the heat that's in the return air to boil the water vapor to raise the humidity to the right conditions for the manufacturing process. So common to see that kind of humidifier used in that kind of very specific manufacturing process. So that's the adiabatic humidification process on a site chart. Thanks a lot.